Hello class, and welcome to today's lesson, which is the second part of section 5.5, talking about solving multi-step inequalities. By the end of today's lesson, you will be able to solve and graph multi-step inequalities. So, we're going to start with just basic ones, basic two-step. We're going to solve by undoing our operations. So to get rid of this addition, I'm going to subtract 8 on both sides. And I've got 4 is less than or equal to 4x. And then I'm going to go ahead and get rid of that multiplication by dividing on both sides. And I'm going to end up with a statement of 1 is less than or equal to x. So because I've got less than or equal to, when I go over to 1, I'm going to put a closed dot, so filled in. And now the statement says 1 is less than or equal to x. So this says 1 is smaller than the numbers or smaller than my answers. So my arrow is going to be going to the right. 1 is smaller than all of these numbers that are to the right. Go ahead and try this one on your own. We add the 17 and divide by -3. Remember, when you divide or multiply by a negative, you need to flip that inequality sign so it flips to x is greater than 7, giving you that open dot at -7 and going to the right because we want the values that are greater than -7. Just like with equations, if there are parentheses to start in your inequalities, you are going to distribute as your first step. So we've got 4 times b, which is 4b, and then 4 times -3, which is -12, is greater than or equal to 72. To get rid of subtracting 12, we're going to add 12 to both sides of the inequality, and I get 4b is greater than or equal to 84. And then to get rid of multiplying by b, I'm going to go ahead and multiplying by 4, I'm going to go ahead and divide by 4 on both sides, giving me that b is greater than or equal to 21. Currently on my number line, I would be counting by 1 since there is no label. If I want to count by something bigger, which I will need to in order to get to 21, I can renumber. 21 is divisible by 3, so I'm going to go ahead and count by 3s. So 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So I've got a closed dot. We fill that in because it's got the equal to part. Then it says I want b is greater than 21. So I want all of the numbers that are bigger than 21. That is to the right of my dot. So anything to the right satisfies this inequality. Sometimes there's going to be parentheses on both sides of the inequality. When that occurs, we want to start by doing the distribution on both sides. So I'm going to end up with 4x plus 20 is greater than 6x plus 12. Now, when you are moving your variables from side to side, remember, if you have to multiply or divide by a negative, you have to flip-flop the sign. So when you move your variables, you want to try and move the group to keep them positive. So I'm going to take away 4 x's from both sides of the equation. That eliminates the x's on the left side, leaving us with 20 is greater than, and then 6 minus 4 gives me a positive 2x. If I had subtracted 6x from both sides, I would have ended up with a -2 on the left side of this inequality, and then I would have to make sure to flip my sign later in the problem. So I moved the x's to the right side. Now it's just a regular problem. I'm going to eliminate adding by subtracting, and I get 20 minus 12, so 8 is greater than 2x. And I'm going to finish by dividing by 2 on both sides of the inequality. So I end up with 4 is greater than x. So I go over to 1, 2, 3, and 4, and I put my open dot. Now it says 4 is bigger than the answers. So I want all of the answers that are smaller than 4. So that is going to have my arrow moving to the left, saying anything to the left of 4 is included in my answer. Go ahead and try this one on your own. So we distribute that -2. I added 2k to the right side to get rid of that negative with the variable. Then add the 16 and divide by 7. We get 2 is less than k, which means 2 is smaller than all of our answers. So an open dot with the arrow going to the right. Couple more here with a distributive property. I'm going to go ahead and distribute, and I'm going to get 7y minus 14 plus 38 is greater than 7y plus 10. I'm going to go ahead and simplify the left side of my inequality. So I'm going to have 7y, and then -14 plus 38 is going to give you a positive 24. And I end up with that being greater than 7y plus 10. Combining my variables now, I'm going to subtract 7y from both sides of the inequality, which leaves me with the statement 24 is greater than 10. Since 24 is actually greater than 10, that means no matter what you plug into this inequality, you are going to get a true statement. And if anything can be plugged in, that means there is infinitely many solutions. So any number can be plugged in and the inequality can be solved. To graph that, you graph the entire number line from start to finish, saying anything can be included. So when I distribute on this one, my left side is going to stay as 32 plus 10w is greater than or equal to 32 plus 10w. Then I'm going to go ahead and move my variable. So I'm going to subtract 10w on both sides. That eliminates our variable from the inequality, and it says 32 is greater than or equal to 32. Now, because it says greater than or equal to, once again, this is going to be infinitely many solutions because 32 can equal 32. If it had just said greater than, it would not work because 32 is not greater than 32, but 32 is greater than or equal to 32. So once again, if you have infinitely many solutions, it's going to cover the whole number line. Go ahead and try this one on your own. When you solve, you distribute, eliminate that variable, you end up with 24 is less than 24. That is not a true statement. 24 is equal to 24. So this is a no solutions problem, and that graph is left blank. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.